Okay guys, today we're going to finish example 5 from section 1.4, the limit of a function. This is this lesson that we were doing on Monday's class, and we just stopped short of this last example. On Monday's class we were taking the limit of a function, which means that we're trying to find what y value am I approaching as my x value approaches the given point. So in my first example here, in example A, my function is f at x is x minus 3. So this is just a line with a positive 1 slope that's been shifted down to negative 3. And we're going to draw a quick sketch of that afterwards. But because I know that this is a continuous function with no breaks, when I'm evaluating the value of the function as x approaches 2 from the positive side or from the right-hand side, I know that that's going to be the same no matter which side I approach 2 from, because I know this function is continuous. So really all I need to do is figure out the y value of this line when x is 2. So I can do that pretty quickly. I don't really need to do a lot here. I can substitute 2 into the equation, and I can see here that when I sub 2 into the equation, I'm going to get an answer of negative 1, or a y value of negative 1. And then I can sketch this graph really quickly. I'll throw my axes on. This graph is going to be shifted down to negative 3, so I know that there's going to be a y-intercept of negative 3 and then a slope of 1. Oops. And so here I've got my negative 3, and I know that if the slope is 1, that the x-intercept is also going to be at 3. And I can see here at 2 that my graph will in fact be at negative 1. So just a really quick sketch to kind of prove to myself that I think I know where these points are. So you can see here if this is x is 2, this is x is 2. If this is x is 2 right here, then I'll just switch to a pen tool, sorry. If this is x is 2, and this is x is negative 1, I can see here that this is what's happening. And I am approaching 2 from the right-hand side, so I'm approaching kind of in this direction, but I can see that I am in fact approaching negative 1. All right, next function. Next function I'm looking at is f at x is negative 2 over x squared minus 9. So I might remember what this kind of looks like. There are breaks in this graph. The breaks in this graph, so this is not a continuous graph, the breaks in this graph come from what makes the denominator equal to 0. So if I factor that denominator, x squared minus 9, that's a difference of squares. And so I would get x minus 3 and x plus 3. That tells me that there are breaks in this graph when x is negative 3 and x is positive 3. Which tells me that because I'm investigating the limit as x approaches 1, that it is actually continuous at 1. So because of that, I can just substitute in my value, x is 1, and I'm going to get negative 2. I'm going to get negative 2 over, and when I plug 1 into the bottom, 1 squared minus 9 is negative 8. Smooth this over. Oh, nope. Sorry guys, fighting a little bit with the computer here. We get negative 8. And of course this reduces to 1/4. Got kind of a fraction bar here. Oh my. So this is equal to 1 over 4. And again, we'd take that fraction bar, and we get 1/4. All right, so our quick sketch. So we're going to do a quick sketch of this graph. Like we said, the bottom factors to -3 and +3. So I know that I have two vertical asymptotes. One of them is at -3 and one of them is at +3. And then I have to try to figure out, well, what's going on in the middle of this graph. This graph also has a horizontal asymptote at 0. I can tell that because the degree of the top is smaller than the degree of the bottom. When I look for my y-intercept, I'm going to be plugging 0 in for x, and then I'm going to get a y-intercept of -2 over -9, or +2/9. So I know that the middle section of my graph does pass through at -2/9. It's pretty small here. And then the rest of this graph is going to be positive. So it's going to look like this. And I know this from experience, so if you don't remember this from your rational functions, you are going to have to plug in a few points. So you would plug in x is 1 and get that as a point, try to figure out where that is. You'd plug in x is 2, x is 3, all those kinds of things. I also know that for my outer sections then, because again, I remember the behavior of a reciprocal over a parabola, where the parabola has two x-intercepts. This is a reciprocal that then has been flipped vertically. That's why the negative is here, and then stretched by 2. But it still has that same shape of the intersection looking kind of like a parabola-ish shape, the outer sections approaching the vertical asymptote, and then the horizontal asymptote. And then I can take a look for that point on my graph when x is 1. So here I am at x is 1, and I'm looking to make sure that I am in fact getting close to 1/4, which makes sense if my pen was better at drawing, but I don't have a whole lot of control today since I'm at home and I'm using my mouse pad. So there I am, I'm at around 1/4 for height. Remember this point here, the y-intercept was 2/9, so there's a bit of a slope there. All right, our next function here is a little bit different because this time I do have a graph of a reciprocal that's been shifted 5 units to the right. And so my vertical asymptote is at x equals 5, and I want to investigate the limit as I approach x equals 5. So you might have kind of a sense of what's going to happen here if you remember our reciprocal graphs. But what I need to do, because I can't just plug 5 into my equation, is I need to investigate the limit from both sides. So instead of investigating just the limit as x approaches 5 from either side, I'm going to split this, and I'm going to take a look at the limit as x approaches 5 from the positive side, and then as x approaches 5 from the negative side. So let's see if I can find this here. So my notation is going to be a little bit different, so I'm not sure where this is. So I'm going to do x approaching 5 from the negative side first. And so I'm doing that of our function. So I'm doing that of our 1 over x over 5. X minus 5, I should say. So I'm doing that first. I'm coming in from the left-hand side, and so I'm picking a number a little bit smaller than 5, so something like 4.99 or something like that, and I'm imagining plugging that into my equation here. And when I plug 4.99 into the equation and I subtract 5, I am going to get a really small negative number, so something really close to 0 but negative. And so then I'm doing 1 divided by that negative number, so I know that my answer is a negative. But when I take 1 and I divide it into really, really small piles, like 0.001 size, I'm going to get a lot of different piles. So if I'm thinking about taking $1, right, and splitting it into piles of 0.001 or 0001, I'm getting smaller and smaller. There's going to be more and more piles. And eventually, if I get closer and closer to 0, it will be closer and closer to an infinite number of piles. So that's my left-sided limit. Pull that down here. And then I can imagine also from the right-hand side. So again, I can do another equation where I'm going to go in from the positive side of 5. So this time when I'm substituting in, I'm imagining substituting something in that's a little bit bigger than 5, so like 5.001 or something like that. So again, when I plug in the 5.001 and I subtract 5, that's going to give me positive 0.001. So I know that I've got 1 divided by a positive, so I know that overall my answer is a positive. And then I've got 1 divided by almost 0. So again, when I'm taking a number and I divide it by almost 0, I get infinity. And now what I notice is that when I approach 5 from the left, I get negative infinity, and when I approach 5 from the right, I get positive infinity. So this original limit does not exist. And of course, I can draw a sketch of this graph. The sketch of this graph, just running out of space here, just let me move this stuff. This is just a reciprocal graph, so going back to like grade 11, I've got my reciprocal graph with a vertical asymptote at positive 5. It's got a horizontal shift 5 units to the right, and then it's just a regular reciprocal graph. Nothing has changed about it, so I know that this side looks like this, and this side looks like this. And now we can see as we approach that 5 where our vertical asymptote is, remember that this is 5 here. As I approach that from the left-hand side, we can see that we've kind of proven our point here. As I approach from the left, I am approaching negative infinity. And as I approach from the right, I am approaching positive infinity. So of course, I'm not approaching the same value, and this limit does not exist. All right, so that wraps up our lesson for 1.4. You guys had already started this homework, so you'd already done this stuff in the blue writing, but now you're going to complete the rest of the stuff in the black writing. So questions 4 and 5, questions 8, 9, 10, and then try another one from this last set down here. Have a good day, guys.